All right, guys, section 5 of chapter 9, solving quadratic equations by using the quadratic formula. So previously, we solved quadratic equations not just by completing the square, but by factoring, by graphing, several different methods. Now we're going to use what I like to call the supreme of the ways to solve quadratic equations, because using the quadratic formula will work no matter what. It always works for solving a quadratic equation. And it'll work whether you get integers for your answers, decimals, square roots, or even if there is no solution to the quadratic equation, the quadratic formula will show that as you compute it. Now, the thing with the quadratic formula is it is a little bit complicated, so you have to be very careful in how you add, subtract, multiply, divide, take the square root and stuff. You'll see in the formula. And sometimes, for example, factoring might be a lot easier and quicker than using the quadratic formula. Okay, so just be aware of that. I mean, the quadratic formula, like I said, will always work, but it may not be the simplest and most time-effective method to use. Okay, so now we're going to solve quadratic equations using the quadratic formula and talk about something called the discriminant to determine the number of solutions of a quadratic equation. All right, so let's get started on the vocabulary first. Like I said, quadratic formula and something called the discriminant, and we'll talk about that in the second video. So quadratic formula, completing the square of the quadratic equation, ax squared plus bx plus c equals 0. Like if you do the completing the square with that using a, b, and c instead of actual numbers, it will produce a formula that allows you to find the solutions of any quadratic equation. Now, when you get into Algebra 2 and pre-calculus, they might actually go through the steps and show you how to solve the quadratic formula. But right now, we're just going to show you what the quadratic formula is, not how they actually got it. Okay, so the solutions of the quadratic equation, ax squared plus bx plus c equals 0, where a is not 0, are given by this formula right here. Okay. Now, I will say that you have to have the quadratic equation in standard form. It has to have x squared, and a is the coefficient of x squared, b is the coefficient of x, and c is the number by itself. Okay, and the whole thing has to be set equal to 0 before you plug the a, b, and c in. You say this: the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so be very careful. All right, so let's use it. Solve x squared minus 12x equals negative 20 by using the quadratic formula. So you have to rewrite it in standard form, so add 20 to each side. Now, the values of a, b, and c are the coefficients of x squared, x, and 20. And I would add that you take the sign with them. So a is 1, because the leading coefficient of just x squared is understood to be a 1. The b is negative 12. You take the sign with it. And c is 20. Now, if you didn't set it equal to 0, you might mistakenly put c is equal to negative 20, but don't do that. Okay? So it's the opposite of what b is. So it's the opposite of negative 12 plus or minus the square root of negative 12 squared minus 4 times 1 times 20 all over 2 times 1. Now you have to multiply first inside the square root before you can subtract, and you can also do the square right here. So negative 12 squared is 144. 4 times 1 times 20 is going to be minus 80. And the opposite of negative 12 is positive 12, and the 2 times 1 gives you 2. Okay, then you can subtract the square root of 144 minus 80 gives you the square root of 64, which is 8. So you do 12 plus 8 over 2 and 12 minus 8 divided by 2, and you get your answers 2 and 10. So those are the two solutions. Now let's do a couple more together just to show you how to get used to the formula. This one, x squared minus 2x minus 15 equals 0. It's already set equal to 0, so my a is 1. My b is negative 2, and my c is negative 15. So x equals the opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 1 times negative 15 all over 2 times 1. So the opposite of negative 2 is 2, plus or minus the square root. Now be careful, negative 2 squared is 4. Now 4 times 15 would give you 60, but it's negative 4 times negative 15, which would give you positive 60, all over 2. So that's going to simplify to 2 plus or minus the square root of 64 all over 2, which is 2 plus or minus 8 over 2. So your one answer would be x equals 2 plus 8 over 2, which is 10 over 2, or 5. And the other one is x equals 2 minus 8 over 2, which is negative 6 over 2, or negative 3. So x equals 5 or negative 3 would be your solutions for that one. Okay, one more. I think I have one more here. Yep, x squared plus 16. Now be careful with this one. A is equal to 1, and B is the coefficient of the x term. Now watch this. The coefficient of the x term is going to be 0, because there is no x term, and C is equal to 16. So it's going to be the x equals the opposite of B, which is negative 0, plus or minus the square root of 0 squared minus 4 times 1 times 16 all over 2 times 1. So you end up with 0 plus or minus the square root of negative 64 all over 2. Now here's the thing. You can't take the square root of a negative number. That's how you know that there is no solution. Okay? If you have to take the square root of a negative and you did all the steps correctly and you get a negative under the square root, you did things right. It just means there's no solution to the problem. Okay? So that comes up from time to time. All right, here's one for you to try. Go ahead and pause the video. Okay, we're back. First thing you want to do is subtract the 18 from both sides to get it set equal to 0, and identify your A, which is 2, your B, which is negative 9, and your C, which is negative 18. And x equals the opposite of B plus or minus the square root of negative 9 squared minus 4 times 2 times negative 18 all over 2 times 2. So that's going to be 9 plus or minus the square root of 81. Now 4 times 18 is 72 times 2 would be plus 144 all over 4. Let me just double check to make sure that I did that right. So I would have negative 4 times 2 times negative 18 gives you 144, right? Add to that 81, and you would get 9 plus or minus the square root of 225 all over 4. And if you figure it out, the square root of 225 is actually 15. Square root 225 just to show you is 15. So it'd be 9 plus or minus 15 over 4. So move that out of the way. You end up with x equals 9 plus 15 over 4. So 9 plus 15 is 24 over 4, which is 6. Or x equals 9 minus 15 over 4, which is going to be negative 6 over 4, or that reduces to negative 3/2. Now, it's okay to have a fraction as your answer. Okay, you can even get decimals, like crazy decimals and square roots and stuff, and we'll talk more about that in a little bit. Alrighty? All right, solutions of quadratic equations are not always integers. So let's solve this one and round our answers to the nearest 10. It's already set equal to 0. My A is 3, B is 5, C is negative 12. When I plug those into the quadratic formula, I would get negative 5. Square root of 5 squared is 25. And 4 times 3 times negative 12 gives you positive 144. The 2 times 3 is 6. And that gives you negative 5 plus or minus square root of 169, which is 13, all over 6. So I would do negative 5 minus 13 over 6 and negative 5 plus 13 over 6. Okay? Make sure you subtract or add in the numerator first before dividing by the 6. And you end up with negative 3 and 4/3. And so those solutions are negative 3 and 4/3. Now this said round to the nearest tenth. 4/3 is actually 1.3 repeating. So you could round it to 1.3. All right. Here's another one. 10x squared minus 5x equals 25. First thing you got to do is rewrite it in standard form. So you got to subtract 25 to both sides and identify the a, b, and c. A is 10, b is negative 5, c is negative 25. So you have your quadratic formula. Plug in your a, b, and c. So it's going to be the opposite of negative 5 plus or minus the square root of negative 5 squared minus 4 times 10 times negative 25 all over 2 times 10. Simplify those a little bit. The opposite of negative 5 is 5. Negative 5 squared is 25. 4 times 10 times negative 25 would be negative 1,000, but you're subtracting it, so you get plus 1,000. 2 times 10 is 20. And then you get the square root of 1,025, which is not a perfect square. Now watch. If I do second square root 1,025, you get a decimal. Okay? So it's not a perfect square. So here's what you do. You take one for the plus and one for the minus. So 5 minus square root over 20, 5 plus the square root over 20. And then what you have to do is do the numerator first. So 5 minus second square root of 1025. Figure that out and then divide that by 20. And you get negative 1.35078, blah, 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 blah. Said round to the nearest tenth, which is where the 3 is, and the 5 would make it round up to a 4. So it's negative 1.4. Then the next one you do 5 plus second square root 1025. Add the numerator up, then divide that answer by 20, and you get 1.8507, which rounds to 1.9. Okay? Alrighty, here's a couple for you to try. Go ahead and pause the video. Okay, we're back. Now, number 2a, the value of a is 4, b is negative 24, and c is 35. So x equals the opposite of negative 24 plus or minus the square root of negative 24 squared minus 4 times 35 all over 2 times 4. So that's going to be 24 plus or minus the square root. So negative 24 squared is 576. 4 times 4 times 35 is 560. So it's going to actually be subtracted by 560. So it's going to be 24 plus or minus the square root of 16 over 8, which is 24 plus or minus 4 over 8. So x equals 24 plus 4 over 8, which is 28 over 8, or 14. 7 over 2, which is 3.5, or x equals 24 minus 4 over 8, which is 20 over 8, which is 2.5. Okay? All right. The next one, a is 3, b is negative 2, c is negative 9. So it'd be x equals opposite of negative 2 plus or minus the square root of negative 2 squared minus 4 times 3 times negative 9 all over 2 times 3. So you would get 2 plus or minus the square root of 4 plus 4 times 3 is 12 times negative 9 would be negative 108 times the negative would be positive 108 all over 6. And that gives you 2 plus or minus the square root of 112 over 6. The square root of 112 is not a perfect square, so you would have to do x equals 2 plus square root 112 over 6, and x equals 2 minus square root 112 over 6. So on your calculator, you could do 2 plus the square root of 112 divided by 6, and you get x equals 2.1 if you round it, and then 2 minus the square root of 112 is negative that divided by 6, and you get negative 1.4. Okay? All right. Move this out of the way. Okie dokie. You can solve quadratic equations by using one of many different methods, and no one is always the best. So for this one, rewrite the equation in standard form. So set it equal to 0. And one of the methods we learned is graphing. So if we graph it, you can locate the x-intercepts of the graph, which look like they're -2 and 6. Now, of all the methods we learned, the least efficient and least effective is graphing for a couple reasons. It takes a lot of work to be able to graph it, and often you end up having to figure out what the x-intercepts are anyway to be able to graph it, and that's the solutions. Second, lots of times the solutions aren't integers, so they fall somewhere between integers, like in a decimal, and it's very hard, if not impossible, to figure those out as exact answers just from looking at a graph. So I almost never recommend solving quadratic equations by graphing. Second method we learned was factoring. This is usually my first go-to step when I solve a quadratic equation, because it is most times the quickest and simplest way. Although not all quadratic equations can be factored. That doesn't mean there's not a solution, it just means you can't find the solution by factoring. So lots of times, especially if the leading coefficient is 1, I try factoring. So look for factors of -12 that add to 4, they're -6 and 2. Use the zero product property, set each factor to 0, then you get x equals 6 or -2. Another method we learned was completing the square. Now this one, again, will always work, but there are several steps. Okay, now we're doing the same problem, just showing you different ways to do it. You have to isolate the x squared and the x terms. Make sure the leading coefficient of the x squared is 1. If it's not, divide everything off by whatever the coefficient of x squared is. Take half of the x term and square it, and add that to both sides. Then you could write the left side as your factored form of the perfect square. Then take the square root of both sides. Don't forget about the plus or minus. And then you take each one. So you would have x equals to plus 4, which is 6, or x equals to minus 4, which is -2. If I use the quadratic formula, in this case, the a is 1, the b is -4, and the c is -12. Plug those in, and it simplifies to 4 plus or minus the square root of 16 plus 48 all over 2, or 4 plus or minus square root of 64, or 4 plus or minus 8 over 2. And if you do the minus 8, you get x equals -2, and if you do plus 8, you get x equals 6. Again, same problem, we just showed the 4 different methods that we learned. Okay, so let's try a couple more together here. The first one, number 7, okay, since it looks a little bit complicated, I would automatically go to using the quadratic formula right there. I mean, you could try to factor it, but you have to multiply the 2 and -6, and you get -12. Actually, that might actually be a little bit quicker in this case. So let's try factoring. 2 times -6 would give you -12. And I'm looking factors of -12 that add to a positive 11. Since the 11's positive, I know my bigger factor is going to be positive and my smaller factor is going to be negative. So start with 12 and -1. That adds to 11. I get it right off the bat. So 2x squared plus 12x minus 1x minus 6 equals 0. Okay, the first set, I can factor out a 2x, and I get x plus 6. Second set, I'd factor out a negative 1 and get x plus 6. Then I factor out the x plus 6, and I'm left with 2x minus 1. And then I set each one equal to 0. X plus 6 equals 0, which would give you x equals negative 6. And 2x minus 1 equals 0. So you'd add 1, divide by 2, and you get x equals 1/2. Okay? All right. Now, number 8, if I multiply the 2 and negative 6, I would get negative 12 again. Okay? The bigger factor has to be negative, so negative 12 and 1 give you negative 11. That's not going to work. Negative 6 and 2 gives you negative 4. That's not going to work. Negative 4 and 3 gives you negative 1. That's not going to work. And that's all the factor pairs. Okay, so factoring isn't going to work here. So now I would use the quadratic formula with a equals 2, b equals negative 3, c equals negative 6, and x equals the opposite of b plus or minus the square root of negative 3 squared minus 4 times 2 times negative 6 all over 2 times 2. That's a 2. So that gives you 3 plus or minus the square root of 9. 4 times 2 is 8. 6 times 8 is 48 plus 48 all over 4, which gives you 3 plus or minus the square root of 57 all over 2. So x equals 3 plus square root 57 over 2, which, if I plug it into my calculator, 3 plus the square root of 57 divided by 2 is going to give you 5.3. And then if I do x equals 3 minus the square root of 57 over 2, 3 minus the square root 57 divided by 2 gives you negative 2.3. Okay? Cool. All right, number 9. First set it equal to 0, x squared minus 25 equals 0. And I notice right away it's difference of squares. Like this is 3x quantity squared minus 5 squared equals 0. So I can factor it into 3x minus 5 and 3x plus 5 equals 0. Now, you could use the quadratic formula. In that case, a would equal 9, b would equal 0, and c would equal negative 25. Okay? But we're not going to do that because we could factor it using difference of squares. Set each factor equal to 0 at this step. So this set equal to 0, and then 3x plus 5 equals 0. So in this case, you add 5, divide by 3. In this case, you subtract by 5 and divide by 3. You get your 2 answers there. Okay. Last one, x squared minus 9x equals negative 19. So I would add 19 to both sides. Now, if you try to find the factor pairs of 19 that add to negative 9, it's not going to work because 19 is prime. And since you have them multiplying to a positive and adding to a negative, the only factors, you'd have to have them both be negative, and the only ones you have are negative 19 and negative 1, which would give you negative 20. Okay, obviously that's not going to work there. Okay? So you have to use a quadratic formula. A equals 1, b equals negative 9, and c equals 19. So x equals the opposite of b, which would be negative 9, negative 9, which is 9, plus or minus b squared, which would give you negative 9 squared is 81, minus 4 times 1 times 19, all over 2 times 1. So it'd be 9 plus or minus the square root of 81 minus 4 times 19, which gives you 76 all over 2. So it's going to be 9 plus or minus the square root of 5 all over 2. So x equals 9 plus square root 5 over 2, and x equals 9 minus square root 5 over 2. So we can bust out the calculadora for this. You get 9 plus the square root of 5. Get that answer first, then divide by 2, and you get 5.6. And then you'd have 9 minus the square root of 5. Divide that by 2, and you get 3.4. Okay, so those are our two answers there. Alrighty, so here's the general idea of what we had. You had factoring, which you can use when the constant term is 0 or if the factors are easily determined. Not all equations are factorable. And remember, if you can't factor it, it doesn't mean the answer is no solution. It just means you can't get the answer with factoring. You could use graphing, you could use square roots, you could solve by completing the square, and you could solve by the quadratic formula. Here's a couple for you to try. Go ahead and pause the video. Okay, we're back. So I don't know what method you used for 3a, but you will get x equals 8. It's an ugly looking 8. You get x equals 8 and x equals 1/2. For 3b, the answers are about x equals 2.2 and x is about -1.2. Okay, if you want me to work through those, just shoot me a message or come into my office hours and we'll go over those in more detail. All right, well, that's it for this section. I know that was a long one, but we had a lot to cover and we had to go into some serious detail there. Okay, so stay tuned for the next video. See you there.